And what about you? In the garage today we have an AMG TF, and the problem with this car, it has a failed O2 sensor. So in this video I'm going to talk a wee bit about O2 sensors, and we're going to test it on the car, see what testing we can do, and well, we'll talk about how these things work. So on the bench here we'll have a few sensors and a few tools that I have to take them out. Now, yeah, these are all pretty much have their purpose depending on the location. So these are handy if they're in the top of the kit and you have to sort of shove it in a bit. And it's quite a narrow thing for the wire there, so I'll have that one that's a bit wider. That one there is good and wide, but because there's too much of an opening on it, it actually can, jump round on you. So these are all 22 millimeters, because, well, all these in here anyway are 22 mil head there, So that one there's not bad. So some of the best tools that I have, my favorites as it were, my favorite actually is this one, to be honest with you, and actually that one, because that one's 12 sided, as you can see, so it's more versatility with it. But this one here is just a crow's foot, and I like this. This is sort of my go-to one really, and it is not sold as a Lambda Sensor getter-outer tool, So this is 22 mil crow's foot. This is on the Amazon store. It's made by Laser, and it's at the time of recording here now. The time of recording, there's 37% off this. So it's not that expensive, and what I like about it is its versatility or flexibility. So if you put it in sort of that way, that'll go nearly anywhere you want. That way there, it'll go as far as there. So you can put it downside up or upside down, and it has this. Let me see if I can get this in the shot. It has this bit here at the back, so it's not just that thin. It's good and thick, so you get a good purchase on it. So I like that. The Amazon shop, there are links in the description and the pinned comment in all the videos. That's the home page. You get down into hand tools, and that opens up all the different hand tools there. So there's it there, that crow's foot, 22 mil crow's foot, and 37% off. It's £11 something or other there, and it's a Laser 6925. So what you can do with it is there's a big half-inch extension. So you can put that as long as you want. You can hit that a couple of blotters if you want. So we'll show getting the Lambda sensor out of this car behind me here, and it's quite awkward position, as you'll see, and we'll use this. Oxygen sensors. So there's a couple of different types. There's different types of everything in there. So these ones over here, I've sort of separated these out. These are old ones I had lying about that I've taken out this years ago. But you can see that they're all 4 wires, and you have 2 wires the same color and 2 different color. Same with this one. 2 wires the same color, 2 whites, and whatever else that is. There we are with this one as well. So let me see. What have we got? On this sort of side here, we have 6-pin ones, but there's only 5 wires. 6-pin, 5 wires. Same with that one. 6-pin, 5 wires, because there's a resistor in here that goes across 2 of the pins. But these are AFR sensors. They're not known as O2 sensors. They're air-fuel ratio sensors, and work completely differently. In this video, we'll just stick to these ones, and we'll talk about how they work. These ones here, apart from that one, these ones here are known as O2 sensors or Lambda sensors, and some people call them tomato sensors, but I'll tell you why in a moment. So anywho, these are also known as narrowband sensors. See, whenever these AFR ones come out, these are known as wideband, so whenever they were called wideband, that sort of give them these other ones, these older ones, the name of, well, these in our narrowband, they're wideband, narrowband. I'll show you why that is. And an explanation, hopefully not go on for too long about this. A lot of people might already know this stuff. It's pretty, it's been around for years. O2 sensors, invented by Robert Bosch, late 60s, 70s, and there are a few idiosyncrasies about them. The main one is that it's called an O2 sensor or an oxygen sensor, but it doesn't actually directly measure oxygen. So what it actually does, it compares the oxygen from the atmosphere to the lack of oxygen in your exhaust stream. So you can see here there's holes in this, and that's where the exhaust gases go in. But oxygen from the atmosphere gets in here, and the oxygen is able to pass in. So inside this bit at the end here, inside this bulb, there's like two, if you imagine it's round, but there's like two sort of plates. So the oxygen from the atmosphere goes onto this plate, and the exhaust gases onto this plate. So if it's too rich, for example, it draws in more oxygen, and that passes to this other plate, and that generates its own voltage. So these O2 sensors, and as I said, some people call them, well, they're also called a Lambda sensor. Some people call them tomato sensors because it doesn't, as I said, it doesn't directly measure oxygen at all. It's making a comparison between the lack of oxygen in the exhaust gases and the atmosphere, the outside air. So Lambda is a Greek letter, and it's used in loads of different places. It looks like an upside down Y, It's used in loads of different places in physics and mathematics and stuff like that, for different reasons. But if the readings from the O2 sensor are at lambda, it's said to be unity. So on the air fuel ratio sensors there, you're looking for this figure. It just on the live data it just says 1, so either side of 1 is rich or lean, and it shows the live data the opposite to these narrowband sensors, these older style sensors. And these sensors only work whenever they're really hot, so roughly about 300 degrees centigrade, about 650 Fahrenheit, something like that. And so the early ones didn't have a heater in them, so we're trying to make this process occur quicker. So this is to get the car to go into a loop condition, a closed loop. So the fuel and air going in, and then getting burnt with an explosion, and then whatever's coming out, it reads whatever's coming out, and then alters the fuel and air to suit. So that's the loop it's talking about. So anyway, we'll move on. So if the lambda's not reading anything, it normally sets about 0.45 of a volt. So that's your flat line. And if your mixture is rich, it'll go up to about 0.9 of a volt. So on your live data, or even on a voltmeter, graphing voltmeter, you'll see this sort of waveform. That's what you're looking for. So this is what you hear people talking about. We're looking for the thing to switch. So it switches between 0.9 volts and probably about 0.1 or something like that, So this is rich, this is lean, But the problem with these sensors, and the reason why they're called narrowband, is it doesn't actually maintain it at the ideal stoichiometric ratio, which is 14.7 to 1 air and fuel. So that is the ideal burn combustion for petrol. So the ECU is trying to achieve this stoichiometric ratio. It's trying to achieve that, and it does this by going rich and lean. So it sort of averages out. So really, the place where it actually is correct is this sort of area here, and it's a very narrow sort of place. So that's where this narrowband thing comes from. So it's only a small period of time. So it actually really only goes correct on the when it goes down there, you know, and then it starts to go rich again. So when this air fuel ratio 14.7 to 1 is achieved, it is said to be at lambda. Quick demo: oxygen sensor in the vise on just a multimeter here. So we need to put a bit of heat into this. So what we're trying to do is the denser outside air needs to rush in whenever it gets a bit of heat into it. So that's why they only work when they're warm, and that's why a lot of them have a heater in it to speed up that, accelerate that process. So we'll see if we can get anything out of this with this flame. So we'll take the oxygen away with this flame. If we stick the flame into it, but we need to get it a wee bit of heat into it first, just to get the outside air to go inside. See if there's any activity here. Anything happening? Not yet. Oh. Yeah. Starting to go. Right, so there's air getting into it from the outside. There's air being rushed in. So what we'll do is we'll take this flame then, it'll take the oxygen away if we stick it right in to the other part of the sensor, and we'll drive it rich, as it were. So we'll see if we can go to the 0.9 here, 0.8. .86. So extracting these sometimes can be a pain. So I found this out exhaust here in the skip, so I could show you. The inside of that's all rusty because it's been lying outside. But anyway, so what happens sometimes with these things is, well, you might get it loosened and then it starts tightening as you loosen, So what's going on there sometimes is these threads here might be, protruding beyond this point, So when you're trying to draw the threads up, it actually tightens, it bungs up inside here. So that is a bit of a pain because you can strip the threads out of this. So if that happens to me, if this doesn't, once you loosen it, just spin out with hand more or less. Once you get it loosened a wee bit, sort of half a turn, that means your panther will go in here, So there's no point at all putting any sort of panther on this whenever it's tight because it's sealed. You can leave that on for years and it won't go in there. So that's, people say, oh, this penetrating fluid's no good and all, it doesn't do anything and all. Well, it doesn't if the thing's tight because it's making a perfect seal, But anyway, once you get it loosened, you may be able to get a wee bit of panther down in and, work it back and forward and stuff. So you want to don't just hoof it on out because you do run the risk of pulling these threads. So that's really that on that. We'll get this one out of the car here. I'll show you. Just one other thing, just forgot before we do that. It's worthwhile having these wee chasers here, wee thread chasers, So if it does bind coming out, you make the threads up again. So that's why we have these. Right, so here we are. As we can see, this one here, this is an upstream sensor, so it's just coming straight out of the manifold there, and then into that flexi just behind you there. So you can see that this is between these two pipes here, and cranking at it from below. So awkward enough this, if you didn't have you know, an array of tools which you need to have for these things in some cars. So as you can see, let me see, that's not hardly work, but if you put it up that way, we're not going to get anywhere. So that's hitting the sump. So put it in what we're there, and that. More than enough to get our extension bar on. So you can put a big long extension bar on, and we'll just give it a hoof. Gift. Wasn't too tight, actually. And we just have to spin it out the rest of the way. Oh, look at that. Spin it out the rest of the way and let the wire rotate, you know. So you want the wire to be obviously disconnected, unclipped or whatever, so it doesn't twist up. Even though this is a dead one, like, so this is getting scrapped. But there we go. Oh, there we are. This is a narrowband sensor. It's only got 4 wires on it. And normally, now I'm not saying this is the case with every narrowband sensor, but we'll have a black, a grey and 2 whites. So normally any 2 wires at the same colour is the heater. So, and that's supplied with the 12 volts into the O2, up into there, in the relay, and into a fuse. But that same 12 volts is the main 12 volt feed. It also feeds the injectors, feeds the coils, feeds a couple of other components. One of these here then is a 12 volt feed on the plug coming from the harness, and the other one will be a ground. So we don't really know what one's which, but it doesn't really matter. You know, our testing will prove that. So that's just the heater. We did not get a code for the heater circuit. So normally, whenever these the heater inside this, it's just like an element, you know. And if it burns out, you know, like a bulb or a glow plug or something, it burns out, it goes open circuit. That goes high resistance between these 2 white wires here, and will normally flag a code pertaining to the heater circuit. But we're not getting that here, but just for a giggle and for information, really, we'll do a quick test. So we'll have a resistor ohmmeter over there. So you can use an ordinary voltmeter, you know, anything at all really. So 2 white wires there, and I've got back probes on here just so can be a bit tricky to get a good connection. Let's see. There we go. So it's in around 9 ohms there. Oh, must be getting a bad connection. So you need to make sure you're on. Eight and a half ohms, thereabouts. Now, the range for that is temperature dependent. So if that's still in the car and it's warm-ish, you know, and you do that wee test, you know, the resistance might be a wee bit different. So resistance changes with temperature normally. It's not the warmest in here today, but we got 8 odd ohms. The other thing about it is there's about an ohm on these leads, but this machine here is able to calibrate so it zeroes out. So if I tested that with an ordinary voltmeter, it would probably be in around the 10 ohm mark. So you're looking at roughly something about 3 to 15 ohms, something like that. But if it's kilo ohms, mega ohms, whatever, it's open circuit, and that's it. Heater's no good in it. So down the engine bay then, we can see our 2 heater wires there, the 2 whites, and the plug goes in that way. So those bottom 2 pins will be pertaining to the heater. So the ignition on, we should have, in this car anyway, we should have 12 volts to the heater, and then it'll be ground side switched. So what I have here is the battery is in the front of the car in this. So I have this wee plus and minus. So that's just coming from the battery. That's all that is, just an extension lead. And that wee thing there is just, you know, so I can connect onto it with my test light. That's going to go on there. Get that out of the way. So we should have 12 volts on one of these two bottom pins pertaining to the heater. So there we go. 12 volts in that one. So that's our live feed. So that's that 12 volts that we saw on the wiring diagram. That is also doing the cam sensor, and in this car it actually does the ignition coils and the fuel injectors, and it's the main 12 volt feed. But anyway, the thing we're interested in is the signal. So when we had a look at the live data, we're getting 0.45 volt or thereabouts, just flat line, no activity. So what we want to prove the wiring here, you know, we saw 0.45 volts whenever we back probed there, and that matched up with the live data. But we'll just prove our wirings here, and before we go out and buy an expensive Lambda sensor. So we need to have a positive here at this side of the test light. So I'm going to swap this over to positive. So on a normal car you would just swap it over on the battery, but this is the same thing. You need to make sure that doesn't touch anything. So that'll be fine. And so we'll have a signal and a ground basically. So one of these top two pins here is going to be the signal, and one of them is going to be a ground. So there's our ground. And we have nothing on the signal at the minute, but we can clearly see our ground. So that top one is the signal. So this is what we're interested in here. Bank 1, sensor 1, and it's sitting at 0.47, and that's with the O2 sensor unplugged, so no O2 sensor plugged into that. So it's sitting at just shy of half a volt. So that is sort of like the mid line, and then, you know, whenever the engine's running and the sensor is active, it'll go to 0.9 and then back down. So that's the mid, is 0.45, you know. So what we're going to do is pull that signal down. So with our test light on the positive there, that found our ground in the plug. So pertaining to the Lambda signal output. So what we're going to do is we're going to pull the signal to ground. We know that the end one there, the end pin, is the signal output going to the ECU. So that's coming out of the Lambda sensor. So we'll have that on the negative, you know, or you put that onto the negative terminal of the battery. So this is just an extension lead, as I said. What I'm going to do then is I'll get that out of the way, and we're going to touch that onto the signal wire. So the test lamp won't light up or nothing, but what we're doing is giving it a ground through the resistance of the bulb of the test light, you know. So we're going to pull the signal down. It's this 0.475 there. So oxygen sensor voltage, bank 1 sensor 1, 0.475. So that's what's coming out of the ECM. So we're going to pull that down, and this is going to make sure the wiring's good, you know, back to the ECM. So what I'm going to do is put the test light on that extreme left pin, and we'll give it a wee quick touch, and there we go. And it recovers when I take the test light off it. So there you go. So just in case you're wondering, it just depended on what way I was holding that, I think there. Well, you know, don't go by that was the top one or the bottom one. So yeah, so it flips around. So from that bit of testing there, we have determined that we have a 12 volt for the heater there. And we didn't test the switch to ground. You know, you could do that. You'd need to have the car running for that. For completeness, I'll just show the heater circuit working on this test light. we had the voltmeter on this one, and it matched to the live data, and we're able to manipulate that signal. So that's the main thing what we're doing here, is manipulating that signal, and we know we have a good ground here. So these two pins that are pertaining to the signal. So that's what we're interested in. So on that basis, then I'm going to order a new Lambda Sensor, O2 sensor, if you can come out. So this is actually made by Bosch, so we're going to order our Bosch O2 sensor. And a new one has finally arrived. One wee thing to note about these, maybe before you sort of put them in, or if you're putting an old one back in again, is these normally come with what looks like graphite grease on them there. Yeah, there's it there. And you do not want to get grease of any description up in them there holes. These things are really susceptible to silicone or any sort of silicate, and well, that ruins them. I'll get this new one. So no need to chase the threads in these, because that came out like a sweetie. Get that tightened up. So new sensor installed. I've just back probed in the two outputs there. So we'll have a wee look, see if this thing's going to switch from open loop to closed loop, and we'll have a look at both live data and the output voltage. There we go, within the closed loop, pretty quick. Engine coolant 21 degrees. So as you see our short term there, -3, long term. That's short term, long term there. For bank 1, sensor 1, bank 1. -3 and 1.5, so that should start altering the fuel and air mixture. So this is the actual voltage. This is basically just a voltmeter here. And we've got them going side by side. This is going to be the data of the voltage. Well, we'll select the voltage of that Lambda sensor from the ECU. So this is going to be processed data that's went through the processor. So we'll deselect all, and where is it? Oh, I missed it. Voltage bank 1, sensor 1. That's it. Graph view. Yeah. So this is the data from the ECU, the voltage that's measured in the ECU, the processor. So let me see, what's that? 20 seconds. Changing it there. Put that back to 20 seconds. Maybe as a sweep, as Snap-on calls it, instead of a time base. So this is what we're talking about when we want this to switch. So it's going rich, it's going lean. It's not just getting to the 0.9 there, 0.8 something or other, and down to 0.1. So that's it, rich, lean, rich, lean, rich, lean. And somewhere on the down slope here is where it's actually getting the correct fuel and air mixture. So that will then be reflected in our fuel trims. So let me see. Where's the fuel trims? Short term, long term. So short term, around about 3, 7, jumping up and down a bit. -2 in the long term. So a few revs and what have you, and we'll see this changing maybe. Well, the O2 sensor is definitely working, so yeah, take it for a test drive. We'll call it a fix. Okay, maybe get something out of it. Many thanks for watching, as ever, and all the best. And
High five.
high five.